Quality control of ointment and creams. What is semi-solid? Semi-solid, the dosage forms are the topical dosage form used externally for the therapeutic, protective, or cosmetic function. Semi-solid involves ointments and creams. First, ointments are semi-solid preparation intended for topical application. They are used to provide a protective and emollient effect on the skin or carry medicaments for treating certain topical ailments. They are also used to deliver drug into eye, nose, vagina, and rectum. Ointment intended for ophthalmic purposes are required to be sterile. When applied to the eye, they reside in the conjunctival sac for a prolonged period compared to solution and suspension and improve the fraction of drug absorbed across ocular tissue. Ophthalmic ointment are preferred for nighttime application as they spread over the entire corneal and conjunctival surface and cause blurred vision. Second, creams are basically ointment which are made less greasy by incorporation of water. Presence of water in creams make them act in emulsion and therefore are sometimes referred as some semi-solid emulsion. Hydrophilic creams contain large amount of water in their external phase. For example, vanishing cream. Hydrophobic creams contain water in the internal phase. For example, cold cream. An emulsifying agent is used to disperse the aqueous phase in the oily phase or vice versa. As with ointments, creams are formulated to provide protective emollient action or deliver drugs to surface or interior layers of skin, rectum, and vagina. Creams are softer than ointments and are preferred because of their easy removal from containers and good spreadability over the absorption site. Quality control. Quality control is that part of good manufacturing practice which is concerned with sampling, specifications, and testing, and with the organization, documentation, and release procedure which ensure that the necessary and relevant tests are actually carried out and the materials are not released for use, nor product release for sale or supply until their quality has been judged to be satisfactory. Each holder of a manufacturer authorization should have a quality control department, should be independent from other departments, and under the authority of the person with appropriate qualification and experience, who has one or several control laboratories at his disposal. Adequate resources must be available to ensure that all quality control arrangements are effectively and reliably carried out. Requirements of quality control. 1. Adequate facilitate, training personnel, and improved procedure are available for sampling and testing starting materials, packaging materials, intermediate, bulk, and finished product. 2. Samples of starting materials, packaging materials, intermediate product, bulk product, and finished product are taken by improved personnel and methods. 3. Test methods are validated. 4. Records are made manually and or by recording instrument which demonstrate that all the required sampling, inspecting, and testing procedure were actually carried out. Any deviations are fully recorded and investigated. 5. The finished product contains active ingredients complying with the qualitative and quantitative composition of the marketing authorization. 6. Records are made of the results of inspection and the testing of materials, intermediate, bulk, and finished product is formally assessed against its specification. 7. No batch of a product is released for sale or supply prior to certification by a qualified person that is in accordance with the requirements of the relevant authorization. 8. Sufficient reference samples of starting materials and product are returned in accordance with Annex 19 to prevent future examination of the product if necessary, and that the sample is returned in the final pack. Quality control area. Quality control laboratories should be separated from protection area. Laboratories for the control of biological, microbiologicals, and radioisotopes should also be separated from each other. Control laboratories should be designed to suit the operation to be carried out in them. Sufficient space should be given to mix-ups and cross-contamination. There should be adequate suitable storage space for samples and records. Separate rooms may be necessary to protect the sensitive instrument from vibration, electrical interference, humidity. Special requirements are needed in laboratories handling particular substances, such as biological or radioactive samples. Quality of raw materials. Quality controls for raw materials and active ingredients comprise identity, purity, and content testing and are carried out following the regulation of the pharmacopoeia or according to the customer's own instructions. In a process product and finished product. In a process quality control, IPQC tests are done with a view to remove error from every stage in production and maintain the quality of the final product. With the compendials, the quality of final product depends on in a process control IC test because it helps to incorporate excellence within the product. The qualitative and quantitative parameters of pharmaceutical products are checked by finished product quality control FPQC test. Quality control test for ointments and creams. 1. Physical appearance. Following characteristics must be evaluated for physical appearance of ointment and creams. 1. Cracking of emulsion, separation of oil and water phase, development of granular or lumpy appearance. 2. Marked changes in viscosity. 3. Crystal growth. 4. Cross microbial contamination. 2. Particle size determination. Dilute suitable amount of the preparation with equal amount of glycerol or liquid paraffin as specified in monograph. Mount of mixture on the slide and examine under high resolving power microscope. Count the number of particles with diameter above or below than the specified limit in the monograph. Compare the percentage with the official limit. 3. Weight variation test. 1. Select the 10 filled containers. 2. Remove any label that could lead to weight variation. 3. Cleanse the outer thoroughly, dry and weigh each unit individually. 4. Cut the lateral part of containers, remove their contents by washing, dry them and weigh each unit along with its corresponding parts. 5. Difference between the weights. Give the weight of the content. 6. Calculate the average weight of specifications. The average net weight of the content should not be less than the labeled amount. The net weight of the contents of any single container should not be less than 90% of the labeled amount for 60 grams or less, and not less than 95% of the labeled amount for more than 60 grams but not more than 150 grams. If the requirements are not met, weigh the contents of 20 additional containers. Average net weight of the contents of 30 containers must not be less than the labeled amount. Contents of not more than 1 out of 30 containers should be less than 90% of the labeled amount for 60 grams or less, and not less than 95% of labeled amount for more than 60 grams but not more than 150 grams. 4. Solubility test. The contents should be soluble in 9 parts of water and in 1.7 parts of hot water. The content should be miscible with alcohol, ether, and chloroform. 5. Viscosity determination. Most commonly used viscometer are based on 2 methods. 1. Capillary tube method, for example, Ostewald and Apley-Hall viscometer. These viscometers are used for Newtonian fluids like water, organic solvents, thin motor oil. 2. Rotational type viscometer, for example, coat type viscometer, Brockville viscometer, cone plate viscometer. These are used for non-Newtonian fluids like starch suspensions, honey, shampoo, paints, and blood. 6. Assay of active constant. Assay of active constant should be performed according to official monograph, and the percentage should be within the official limit. For example, salicylate ointment. Dissolve 10 grams in a mixture of 20 ml of alcohol, 95% previous neutralized 2-phenol solution, and 20 ml of ether, and titrate with 0.1 in sodium hydroxide using phenol red solution as indicator. 1 ml of 0.1 in sodium hydroxide equal 0.01381 grams of salicylic acid. 7. Sterility test for ophthalmic ointment. This shall be performed according to official monograph by any of the following methods specified: membrane filtration method, direct inoculation method. 8. Metal particles in ophthalmic ointment. 1. Melt the contents of tin tube individually separately in 60 mm petri dish. 2. Cover the dish and heat at 85 degrees C for 2 hours. If needed, slightly increase the temperature to achieve fluidity. 3. Allow each to cool at room temperature and solidify. 4. Invert the petri dish on the stage microscope, furnishing 30 times magnification and equipped with calibrated eyepiece micrometer. 5. In addition to usual light source, direct an illuminator from the above at an angle of 45 degrees. Examine the bottom of enter petri dish for metal particles. Specification: count the particles greater than 50 micron in any dimension. Not more than 1 tube should contain 8 such particles, and total number of such particles in all 10 tubes should not exceed 50. If the requirements are not met, perform the test on 20 additional containers. Not more than 3 out of 30 tubes should contain more than 8 particles, and the total number of such particles in all 30 tubes should not exceed 150. In vitro release test, a minimum of 12 samples per batch should be used for initial method validation or to demonstrate equivalence. For routine release, a minimum of 6 samples would be expected. The in vitro drug release profile data should be provided in tabular and graphical format. For drug release profile, the quantity of active substance released in mass units per unit area at a given time should be reported. For extant pharmaceutical equivalent test, the cumulative amount of active substance released versus the square root of the time should be linear. The parameter drug release rate should be scientifically different from 0. The 90% confidence interval for the ratio of means of the test and comparator product for the parameters drug release rate and the cumulative amount should be contained within the acceptance interval of 90 to 112%. Lag time should be the same, within 10% if present. The test performance should be recorded, and the records should include at least the following data. 1. Name of the materials or product and where applicable dosage form. 2. Batch number and where appropriate the manufacturer or supply. 3. Reference to the relevant specification and testing procedure. 4. Test results included observation and calculations and reference to any certificates of analysis. 5. Dates of testing. 6. Initials of the person who performed the testing. 7. Initials of the person who verified the testing and the calculations were appropriate. 8. A clear statement of approval or rejection or other status decision and the dated signature of the designated responsible person. 9. Reference to the equipment used.